Hey guys, welcome to the Unbounded medium. Today I wanted to talk about some wireless design principles, in particular in medium to high density environments. We'll be using Ekahau as part of this from predictive modeling, post-validation, spectral analysis. I'm going to bring in Ekahau into some of these. Now this is not intended to be exhaustive, so the topic of wireless design is pretty expansive, and that's not the intent of this video, but I do want to go through some fundamentals of what I go through typically in a medium to high density deployment. I've been myself through some CWDP classes with Devin Aiken. That was 5 days of just intense concentration, 8 to 6, and even with all that, after a whole week, we probably still could have unearthed a few more topics. So that's not the goal here, but I do want to cover some core fundamentals of what I go through as I tackle these type networks. This is going to be kind of, I'm bringing in a customer of mine, if you will, to kind of bring in some real examples of the different topics that we're talking about. I'll bring in video clips, different scenarios that I went through with this customer, so you can kind of compare what's being discussed with real life stuff. So let me kind of start moseying on with our slide deck here. One of the things to keep in mind that I've learned is that there's a difference between what I would call Wi-Fi purist of how we do every design, all the steps involved in that design, versus real budgets and real times. There's constraints that sometimes limit you on how far you can take your design. For example, you may not have budget to go and do anything more than a predictive model. Maybe you don't have time or budget to do a pure site survey on site. Maybe the customer doesn't have that in their budget. Or potentially you can do the predictive model, you can do the site survey on site, but you don't have time to measure every wall, every material that you're up against in a facility. So just keep that in mind. That's one thing I've learned. Sometimes you don't get to do all the check marks that you typically would want to do in a full-blown design model. So let me kind of set up the customer, if you will. It's a church. I live in South Carolina, a church in South Carolina, a larger church. They're roughly 2,000 member church. What they did was kind of neat. They took an old Winn-Dixie grocery store and they gutted it and kind of built from scratch their church. So they got some really cool elements in there, really large children's facility. It's got like an indoor playground set like you would see at a Chick-fil-A, so that's pretty cool. And they also have a full-fledged cafe that serves breakfast and lunch, not just on Sundays, but throughout the entire week. So that's a pretty cool element. And of course, like any church of that size these days, they're live streaming their service as well. They're a very digital conscious church. So a lot of their initial initiatives are very digitally focused. So obviously when I met with them, they're telling me their pains. I'm there for a reason, right? So for the most part, wireless and overall internet bandwidth is serviceable during the week, not Sunday services, but just during the week. And even with that, their cafe during the week when people would come in to get breakfast or lunch, even that would struggle at times with just a few people. And so it turned out they really, throughout the entire facility, had only 4 access points and 20 megs of internet. So as we discuss this further, you'll see where that's a huge challenge. One of which is their worship center. It's a 1,000-seat worship center, and they only had a single AP in that worship center. So you can imagine on Sundays when people start coming in, you got a 2,000 member church. They had 2 services that go on at 2 different times. You can imagine as people begin to show up, that Wi-Fi is trashed. You've got 4 access points that were primarily focused on 2.4, very little on 5 gig. And on top of that, you got a 20 meg pipe and you're live streaming. So you can kind of see the recipe for disaster there, why they were frustrated. And they had some important elements at their church that were having issues. Obviously, POS is important for the breakfast and so forth there on Sundays, but they also have some initiatives around a church app that helps out with sermon notes and things like that, as well as their check-in processes for the children and volunteers. So they had some pains. And typically, as I'm hearing pains, I'm taking the opportunity to kind of explain, almost in an education fashion, why they are experiencing some of those pains. So that's helpful. Some light bulbs start going off, especially for folks that do not understand Wi-Fi, in particular the contention piece of Wi-Fi. So I, in the church's case, I took the opportunity after listening to their pains to kind of explain some of the reasoning behind the pains that they were experiencing. So, we've met them, we've understood and listened to their pains. The next thing we're going to do is gather requirements. We need to understand what they want that wireless network to do, how they want it to perform. This is paramount. This is the foundation of your design. If you don't fully unearth every layer of requirements the customer has, your design is going to be lacking in some fashion. So this is huge. And with any design, you've got to have those scaled plans. Without scaled floor plans, the predictive modeling and the heat maps, all those kind of things with an EcoHow, they don't mean a hill of beans without scaled floor plans. So you want to get that from that facility. And if you can't get them, if they don't have them, find some way to make them. There's a lot of different third-party utilities out there that have the ability to create scaled floor plans for you should you not have those. Capacity, really important there. You've got to understand the density of people and devices that will be on that network. And in some cases, very much like the church, you may have varying areas of density. You may have, like for the church, the majority of the church was a coverage type design. There wasn't any real capacity I had to worry about. But in the worship center, there was a large capacity of density that I had to worry about. So your capacity requirements may be area focused. So sometimes it's not just the entire facility, it could be pockets within the facility. You've got to worry about the capacity, whereas other areas like the church, just pure make sure there's coverage, make sure there's certain signal within the 5 gig or 2.4 bands that you need to make sure are hitting certain areas. Excuse me. For the church, the worship center, their goals, their objectives were to have roughly 800 associated devices with the ability of, in any given time, 400 active devices within the worship center. So not graciously dense, but enough to where you got to put some focus to it. Now, areas of importance. You've got to make sure you understand the areas throughout the facility that are important for that particular customer for coverage, capacity, things of that nature. So there may be areas that mean nothing to them and you can leave them out of your design, or they can be kind of ancillary, overlap, coverage type stuff. So you gotta make sure you understand the areas of importance. And if you can, start unpacking device types that they're expecting to come into their environment. If it's for the most part, a public venue play, a church is kind of a public venue play. Majority of what's coming into the church was kind of a BYOD type scenario. It's the cell phones, the occasional tablets, things of that nature. So there's a little bit of a mix where the staff had some kind of expected device types, iPhones, iPads, things of that nature. But for the most part, the church was a BYOD. So in that case, you want to design around that mindset, design around the worst case scenario, so that hopefully you're covering the 99% of the clients coming into that facility. You need to also understand applications. You need to know what they're expecting to ride on that wireless network. And then you've got to vet out what those applications are expecting when it comes to, for example, bandwidth requirements. Now for the church, it wasn't crazy and wasn't all too complex. They had a few things. Majority of what's centered around was their church app. They've developed a church app that runs on Android, iOS, things like that, that for one part, it's their sermon notes. So that as the pastor's engaging with the members during the services, he has his entire sermon notes in that app. So that as he's going through different bullet points, different illustrations, they're watching that through their device. They're engaging with him through that process on the app. The app does a few other things as well. It's a tithing option as well for the members, where they can tithe on their phone or their mobile device. It also had the ability to kind of bring up previous sermons that they save and archive, as well as it also had the option to view the live stream that they have going on at the service. So you need to understand, of course they had POS too, I mentioned that earlier, but they had a POS initiative that you've got to make sure of. And then of course, like with most anybody, general web browsing, email, things like that. But you may have more complicated applications that are more time and latency sensitive. So voice over Wi-Fi, things like that. So you've got to understand how they need to use the wireless so that you can design it appropriately. Moving on here, so the other thing you need to be careful of is everybody has different thresholds of cosmetic constraints, if you will, mounting, things like that. So you got to understand what's acceptable and what's not, what areas can be used and what can't when it comes to mounting APs. I work with a shop that's a Ruckus shop, and so everything with Ruckus is kind of off-white cream. So I've been asked several times, can you paint it black? Can you do this? So you've got to understand what their expectations are, what's an area you can mount, where you can't mount, things like that. So you've got to be understanding of the different constraints of what you're allowed to do and not allowed to do, areas you are allowed to go into, because as you're doing your predictive model, you've got to stay away from those areas if you're told that that's not going to work. And obviously you want to understand the networks of the SSIDs that they want to establish. Typically I like to keep people to 4 or less, ideally 3 or less. I haven't run into too much of a problem with keeping people within that minimum, but the more SSIDs we have, the more overhead, more management, more beaconing that's on my network that's going to impact the performance of the network. So you try and educate people too on helping and guide them through some of their decision processes. Security obviously is a big one too. You need to understand how they're wanting to secure their wireless medium. For the most part, you got kind of 3 options. You got your open, your PSK, and .1x. In the church's case, everything was PSK, even their public. I tend to encourage people to put PSK on public Wi-Fi within something like a church, not a public venue per se, but you're offering free Wi-Fi, yes, but you don't want to spread it to everyone in this with the range of that RF to potentially saturate the bandwidth. So I typically encourage people to go PSK, or it could be, like I said, .1x. I've done some college campuses where they wanted .1x so that they can have single sign-on for all the students throughout the campus as they go. So they have single sign-on for all things college related, including the wireless. So you want to understand how they're expecting authentication to happen on the network. One thing to keep in mind, obviously device types may also determine the security you can establish. For example, I've been in warehouses where they had old Intermec, .11b handhelds in the warehouse. And so that was a WEP only type device, and I had to enable .11b data rates as well. So you've got to understand every element that you're up against in a given environment. But one note when it comes to your encryption algorithms, if you choose TKIP, keep in mind with TKIP, it will prevent you from using 11N AC data rates. So 11N and 11AC, in order to get those data rates, remember you've got to have AES as your encryption algorithm. So keep in mind of that as you're vetting out the security requirements. And of course, typical building access stuff. When you can get in, when you can't get in. Scheduling, access to closets. Do you need to be assisted and followed? Do you need security credentials? You got to understand all those things so that yourself and your team, your cabling vendors, whoever, they have access to the areas that they need access to. So, one quick thing, I mentioned applications and the bandwidth needs. One thing I want to quickly talk about is the difference between data rates and actual real throughput. So the data rates are just plastered and advertised and marketed all over the place. Big fat data rates, huge pipes. But in reality, the data rate that you see is not the reality when it comes to throughput. So I wanted to kind of compare those two to get some realistic understandings of what to expect on your network. So don't forget, wireless is a half duplex medium. It is not Ethernet, where you're transmitting and receiving simultaneously. That's full duplex. So keep that in mind with wireless. So because of its half duplex nature, and the way it operates, there's a ton of overhead, a ton of contention constantly going on for the devices to contend and get access to the medium. So all that overhead, all that contention, typically what I've seen and what I've been taught is that contention is chewing up roughly 40 to 60% of the available raw data rate. And of course that depends, that fluctuation depends upon the number of simultaneous users on a given access point, for example. But that's a lot, that takes up a lot. And so that huge data rate you're seeing really translates out to very little when it comes to throughput. So I just want to kind of give you some simple examples here. And some of these percentages, I've gleaned from some of the education I've received, some of the courses I've been a part of. These particular categories here are helpful from Devin Aiken helped me kind of categorize these things. But as you can see, one client, you can expect to see roughly 55% of the data rate if you got one client. And you can kind of see it breaking down from there. 5 or less clients, you can get roughly 45% of the data rate and so forth there. But a quick little throughput example, let's say you have 30 iPad Air 2s. Those are 2x2 devices. One AP is 3x3 AP. So typical stuff, we're just going to keep it simple. 20 meg channels, short guard intervals, and let's say high SNR. Let's assume just a really clean space there, right? So those guys are getting 173 megs a second data rate. Being that there's 30 of those guys, you're going to achieve maybe 40% of your data rate. That translates out to 69 megs. But you've got 30 devices using that 69 megs. So in actuality, what was data rate of 173 megs is actually translated out to 2.31 megs per second of throughput. So I just wanted to kind of compare and contrast those two. That sometimes is a confusion for folks. I wanted to make sure we talked about that. So let's kind of mosey on here to site survey. So let's kind of refresh actually for a little bit. So we've met the customer, we've understood their pains, we maybe did some education explanation on why they're experiencing some of their pains. We gathered everything that was important to them in the way of requirements of how they wanted the network to function. Now we're on site. That's assuming we had budget. Once again, I talked about budgets and things of that nature, but assuming we had budget to come on site and do a full-blown site survey, this is kind of what would be the next step for me. And this is when we're incorporating some of the EcoHow pieces. But when I'm on site, I'm taking building measurements. Very, very important there. You've got to measure along hallways. You've got to measure different aspects, ceiling heights, for example, so you know where your APs are going to be placed. We'll talk about this in the predictive side of things, but you've got to have those measurements in order to scale your floor plan properly within EcoHow. So those measurements are very important, and take plenty of pictures. Not only is it going to be helpful for you so that when you're back at the office and you're working on your design, those pictures are going to be helpful to jog your memory of certain aspects of the facility, as well as, and we'll talk about this later, your installers. Typically, I'm not the guy mounting the APs or running the cables, things like that, so I've got to hand off those reports to that installer. Pictures are very important, very helpful, so that what I'm designing is how they're installing. Measuring walls. Now I've got a slide after this that kind of depicts out an illustration of how to measure walls. This is another thing that comes back into the budget. They may not have the budget for you to spend the time to measure every wall, every different obstruction or building material in the facility. So I'll talk about how to do measuring of walls, but that's important too, provided you have the budget for that. Now, EcoHow does have some kind of canned or predefined attenuation levels for drywall, for cinder block, things like that you can incorporate if you didn't have the budget to measure walls. So spectrum analysis. We got to know what's going on at layer 1. We got to know what interferes we may be dealing with in the environment. So it could be interferes that we have control over, that we can take out of the environment, or it could be interferes that I can't do a thing about and I've got to design around them. But we've got to know what we're up against. Layer 1 interference. Interference at layer 1 is going to cause me data corruption. It's going to cause me layer 2 retransmissions. So I need to get around those because that's going to lower the performance of my wireless network. So I got to be careful about that. With with Ekahau, it's got a built-in spectrum analyzer. You can kind of combine that with maybe channelizer to get some signatures of the different RF patterns that you're seeing. But, and I haven't had a chance to play with it, and I've been watching a lot of videos, Ekahau has the sidekick. So that's going to be a game changer when it comes to spectrum analysis. The resolution is pretty insane so far, at least of what I've seen so far. But spectrum analysis of some level so that you know what you are or are not dealing with when it comes to layer 1 RF throughout the environment. It's going to go back to how you design once you get back to the office. You need to know AP mounting options. You need to know, are you dealing with drop ceiling with T-bars? Are you dealing with rafters where you've got to do maybe hose clamps, articulating mounts? Are you dealing with maybe pole extensions and mounting an AP at the bottom of the pole to get closer to the clients? Are you dealing with drywall mounts? You got to understand what you're dealing with so that, once again, when you're designing, you know how to design, especially reporting that you're going to be handing off to the installers. They need to know what they're going to be installing with so that proper mounts and brackets, things of that nature, are being brought to the customer site. Cabling is important. You know, we've got to know all the distances of your cable runs. Is it within the Cat 5, Cat 6 limitations? Is that 300 feet? Are you needing fiber runs? For example, your MDF closets, your IDF closets. You've got to locate those throughout the facility so that you know how your cable runs are going to be architected. Do you need fiber in between your closets? What type of optics are you going to put on that fiber? 1 gig optics, 10 gig optics? You've got to understand all of these elements so that, once again, it goes back into your design. But that's why it's important to be gathering these things as you're doing your site survey, as you're putting your hands and eyes and feet on that facility. So we talked about measuring walls earlier. Let me show you real quick kind of an illustration of the proper way to measure these walls. So with any measurement, it's got to start with a baseline first. So ideally, you'd want to have some kind of scanner. Could be your cell phone. Doesn't have to be this AirCheck G2 that's illustrated here, but it could be any scanner, any cell phone, for example, with an AP. And ideally, I typically like to do this with 5 gigs since we're primarily designing our networks around 5 gigs today. So I like to take my wall measurements using that. But you got to get a base measurement without any obstructions. But the key is that measurement's got to be probably roughly 5 meters to 6 yards separation between your scanning device and your AP. Reason for it is free space path loss. You know, if you look at any kind of inverse charts of free space path loss, you'll see that within the first 3 to 4 meters, you've got a significant change in dB, close to 40 dB change within just those first 3 to 4 meters. Once you get into meters 5 and so forth, it levels out pretty significantly to where you're only seeing a 1 to 2 dB variation. Very important when you're trying to get your baseline measurements of signal strength. If you're within that first 2 to 3 meters, your signal strength is going to go all over the place with just a slight movement of your scanner. That's what's important, to get that separation of around 6 yards is what I've tend to find the sweet spot. So once you have that measurement, you've got to now introduce an obstruction into that distance between your scanner and your AP. And then once you've got your base measurement, you then introduce your obstruction, and you're doing the exact same measurement, just with the obstruction in the way of that same distance. And then you're taking, roughly 3 measurements, give or take, to get an average. And then the difference between your base and the measurement with the obstruction, there's your attenuation. That's how much attenuation is being introduced by that obstruction, be it a wall, door, what have you. And then you can take that measurement and take that to Ekahau. We talked about earlier where Ekahau does have some canned measurements for their walls, drywall, etc. Well, you can take these measurements and tweak that to where it's specifically custom to that customer's environment, so that you're incorporating the true attenuation values for the different building materials throughout the facility. Falls back into budgets. I'll keep saying that. Some customers will not have the budget for you to do this kind of methodical calculation of their environment. So keep that in mind. So let's go to kind of some design methodologies that I have for high density. This, once again, is not exhaustive, but these are some core things to be thinking about as you're designing. You've gone through all the gathering of requirements. You've understood the pains and challenges of the customer. You've done your site survey with all the different spectral analysis and pictures and things of that nature. Now we're back at the office. We're designing this thing. So these are some things that go through my head as I'm designing medium to high density environments. One of which is the capacity side of things. We got to know how to build that capacity up. So, there's different ways of doing it. The way that I've kind of grown accustomed to is using Andrew Vanage's Wi-Fi capacity planner. He's got a new version of it now that's a lot more graphic driven, even includes some mesh options as well. I use the previous version. And so what I would do, now EchoHal, to their defense, EchoHal now has a fairly robust engine for designing capacity on top of the modeling that you do within their software. I have not used that. I'm just comfortable with the capacity planner from Andrew Vanage. But in fact, let me just bring it up real briefly so you guys can see it. This was specifically for the church. You plug in the different metrics, the type of APs, the channel widths that you're using, distribution between bands of the clients. You're plugging in all these different elements. And it's not designed for me to talk about every element of this capacity planner on this video, but this is what I'm using to determine the capacity, the number of radios that I've got to incorporate to a given area to meet the capacity requirements. Minimum basic rates, the type of environment I'm in, the client distribution, the types of clients, and the type of bandwidth requirements within each of those clients. And it starts dispersing those throughout the different bands and so forth based on the information I've populated at the top. And then basically at the bottom here, it gives me kind of a quick rundown of the number of radios that I need to have in the environment, in the area that this is being represented by. It also helps me with determining internet bandwidth, if you notice down here. That's helpful in communicating to the customer what they need to maybe increase their internet up to. If you remember, for Cornerstone, the church, they only had 20 megs when I walked in. So as you see here, I recommended that they increase their internet to a minimum of 200 megs. So I like the Wi-Fi capacity planner, but there's other ways of doing that. EchoHal's got one, but you need to understand the capacity, how to build the capacity within your environment. One thing I always do, unless I have to do it because of specific device types, I always disable lower data rates, all the 11B data rates. And really, for the most part, unless there's a specific reason not to, I always set my minimum basic rate to 24 megs. That seems to be a sweet spot for me. I know a lot of people will argue about 12 megs, but for me, I've found a sweet spot with 24 megs. But that's not in stone. That's typically where I start. And if I see where I need to make some adjustments, I will. But that's typically where I start with my minimum basic rate. Just trying to get the efficiency up. I want to get the 11B protection mechanisms and lower data rates. I want to get that off of the network if I can. And I want to increase that minimum basic rate so that everyone's at high SNR levels as they navigate throughout the facility. High density, it's always 20 megs. In fact, rarely of any of my designs do I go outside of 20 megs. Maybe occasionally I'll throw in 40 megs for very specific bandwidth requirements if the space is clean with RF, but I typically live and breathe 20 megs almost all of my designs. And I also I create my design solely on 5 gigs as I'm navigating through EchoHal. And then I will sprinkle in 2.4, at least no more than half of the radios at 2.4, maybe less with 2.4 turned on. Once again, unless the requirements by the customer are telling me I need more 2.4 in the environment. In some cases, I have no 2.4. 5 gigs is just so clean in most areas. That's how I design everything around. So AP power levels. There's discussion around this, obviously. I mentioned earlier that I work at a Ruckus shop, and so you read any documentation with Ruckus, and they're telling you full power, full power, full power. Obviously, they've got some unique setups with their BeamFlex technology, and that's the reason for their driving the full power conversation. But typically everything I read, everything I've been taught is you want to match the AP power levels to your clients. Typically, what I like to shoot for sometimes is on the 5 gig side of things. EIRP, not IR, but EIRP, shooting for somewhere around the 10 to 13 dBm, something like that. On the 5 gig side, somewhere around 6 on the 2.4 side, something like that. Those aren't in stone, and once again, sometimes I fluctuate that depending upon the environment, and maybe it's cinder block. Maybe it's a college campus where every dorm room is covered in cinder block. So that's not a hard and fast type situation, but sometimes I'm hovering that 10 to 13 dBm for EIRP for the power levels on the APs. Keep in mind though that you want your IR to be at a minimum 3 dBm regardless of the EIRP. So, but like I said, that's not an in stone topic, I guess, when it comes to power levels. To their defense, Ruckus has proven out some things that the full power in some cases does work with their beam flex. So, take it with a grain of salt, but typically I'm adjusting power levels to match my clients that are walking in, the client devices that are walking into the customer's environment. So, and when it comes to high density, talking about the worship center, for example, at the church, you really need to strongly consider directional antennas. You've got to create those small cells of contention throughout a high density environment so you can build up that capacity. So with highly directional antennas, you can do that. Now with Ruckus, it's not external, everything's built in, there's no external option. So for this case, I did the T301Ns within Ruckus, spaced multiples throughout the worship centers. You'll see when we get to Ekahau. But be mindful of that to build up that capacity. Great way of doing that. And I use DFS channels. I'm not afraid of that. I think some people maybe tend to be. But if you're doing scans and you're doing spectral analysis, things of that nature, and you're not seeing any RF radar events, I should say, things like that, I'm using DFS channels all day long, especially in high density. Got to use it. I do tend to stay away from channel 144. I've noticed that some clients are still not supporting 144. So I typically leave that off of my designs. And probably a little deeper than I intend to be on this video. I do want to make mention of transmit beamforming multi-user MIMO. For the most part, I like to try and disable that when I'm in large public venues. This church doesn't fit the build quite as far as the size, but I do want to mention that, with transmit beamforming multi-user MIMO, in order for MU MIMO to work, both the AP and the client have to support both of those, transmit beamforming and multi-user MIMO. And keep in mind, it's only currently with 11AC downlink only, and it doesn't do uplink. Obviously 11AX is coming, but today downlink only for multi-user MIMO. In order for it to work, I'll get to channel sounding in a minute, but in order for it to work, the clients have to be optimally positioned in kind of different directions, if you will, kind of orthogonal, it's hard to say that word, but so that they're kind of differentiated from each other, so that they're separate as the multi-user transmissions are happening. But the clients today are very mobile, especially in public venues, large public venues, ballparks, stadiums, things like that. So the odds of mobile clients being properly or best case positioned throughout a venue and staying in that situation, or even acceptable positioning, those odds are very slim. And so the efficiency of multi-user MIMO in that case wouldn't be seen. Now keep in mind, most BSSs, most networks that we're seeing out there, they're going to be a mixed BSS. They're going to have possibly some legacy stuff. They're going to have some stuff that's non-multi-user MIMO capable. So that's also something to keep in mind. In the way of channel sounding, obviously in order for this multi-user MIMO to work, the APs have got to get channel sounding from the client. And often, these clients are, like I mentioned earlier, moving. They're constantly moving. And so the feedback metrics that are coming back to the AP for that channel sounding, they're having to be kind of constantly processed, if I will. Basically, it's creating overhead on the network that, unless all of your clients or the majority of your clients are multi-user MIMO and transmit beamforming capable, it's creating overhead for no gains in efficiencies. Obviously, there's a lot of arguments. A lot of people kind of fall on certain sides of the fence with transmit beamforming multi-user MIMO. But typically, as I've seen, multi-user MIMO does gain some efficiencies for large frames, but in the real world, majority of our networks don't have large frames. Majority of the frames in our network are smaller frames. And some of the stuff that I've read is as high as 80% of the frames in our network are smaller frames. So something to consider. It's a little deeper than I was intending to go on this video, but something to consider. If your vendor of choice supports it, consider disabling transmit beamforming and multi-user MIMO. If you've got a large density environment where the client base is moving fairly frequently. Now, for Ruckus, I don't have that option. Ruckus does not have the ability to turn that feature off. So DHCP, DNS servers, excuse me, you got to size those relative to your project. In the case of the Cornerstone Community Church, my choice was the Fortinet 81E. That's serving up both DHCP and DNS services for that church, which fit perfectly for that church. But you got to be careful with that. You got to size that appropriately. If you're sitting into an arena where they've asked you to service 20,000 client devices, you got to be very mindful of the equipment that you're housing in that environment to hand out that number of APs, to handle that many of DNS resolution requests, things like that. So Fortinet A1E was great for the church. You may have to go all the way up to things such as InfoBlocks that are extremely robust, but they come with a price tag too. So be mindful of that. And kind of the next couple of bullet points kind of follows that same conversation. I always separate every SSID into its own VLAN, logically separating every SSID. And if the SSIDs need to talk to each other, then I'm routing. I'm taking control of that network. But you got to make sure your scopes are sized appropriately for your environment, for your SSIDs. If it's a public SSID, your scopes have got to accommodate the number of people they're anticipating on that public SSID. But you got to keep in the back of your mind the size of your broadcast domain. Ideally, you like to keep that broadcast domain to 500 devices or less. Sometimes I fudge on that. Sometimes I fudge on it. Like, for example, the church. The church has a public SSID where I went with a /23. So I think that's 510 devices, I think, if I'm correct. So, that's pushing the limit there. But you want to be mindful of the size of your broadcast domains. And you obviously have the ability to do some broadcast submissions to help with that. But kind of keep those guys all kind of tied closely together so that your scopes are sized appropriately for the traffic, the number of requests that are going to be coming in at the frequency at which they're going to be coming in. One other thing I but sometimes do in large public venues is dynamic VLANing, so that I can keep my broadcast domains really small, but still handle a large number of users requesting IP addresses with dynamic VLANing. So once again, a little broader, deeper than I want to go, but something to maybe research yourself. And then, of course, one thing I always do, unless I'm told not to do it by the customer, I'm always turning on client isolation for the public SSIDs. I don't want those client devices being able to talk to each other. Obviously, for maybe corporate networks, in-house networks, what have you, I'll turn off client isolation so they can talk to each other, talk to printers and other kind of assets on the network. But for public stuff, I typically turn isolation on. I enable that. So let's we're going to start talking about some predictive modeling, and this is where we're going to kind of bring in some of the Ekahau concepts. We'll shoot over to Ekahau, and I'll bring up the design I did for the church and show you the different layers as we're talking about this. So let me just update my notes here. Obviously, you had mentioned before, you've got to have scaled floor plans. And so with your predictive modeling, the first step is bringing in that scaled floor plan. And then once you've brought that in, the measurements that you got from your site surveying apply to scaling the floor plan within Ekahau. It's got to know the dimensions, the hallway widths, all that good stuff. It's got to know those things so that it's showing you proper propagation of signal and such. So, and if your customer happens to have multiple floors, a 3D type design, obviously we want to lock those floors. We want to create alignment points to line those floors up, however many it may be, so that we can see the signal bleed between the different floors, so we can make sure our co-channel and adjacent channel interferences are being accounted for. And when I say draw the walls, that's taking that floor plan and laying on to it. Is it drywall? Is it center block? Is it an elevator shaft? What have you, so that Ekahau knows the different materials that it's going through and the attenuation levels of it. That's also where, if we measured walls, where we can modify the attenuation level, and I'll show you that. Now, attenuation areas, that's, for example, like at the church, the worship center has a large density of people, of human beings, if you will. I want to reflect that in my design so that what I'm seeing on heat maps and so forth there, capacity requirements, I'm seeing that as accurate as I can in a predictive fashion. So I'll show you how I created the attenuation areas within the worship center. And kind of talked about it before, but the APs are being located on EcoHow for both coverage and capacity based on your requirements. You'll see on my design for the church where the worship center has a high concentration of directional APs, whereas everywhere else was a coverage design. So you see far more separation in space, and I used the R510s from Ruckus for the rest of the coverage using omnidirectional antennas, obviously. Now, the 301N and the R510, those are both two-stream 2x2 APs. And I chose that because the majority of the devices coming into that environment are two spatial streams or less. And I didn't see the benefit, the added cost of going up to 3 or 4 4x4 APs. So that was my choice on there. And obviously we've talked about those before, but make sure your power levels are appropriate for the given environment. But the channel plan is important too. I do everything static. I don't do any auto, channel fly, whatever you want to call it. Everything I do is static. So you want to make sure that you're choosing a proper channel plan throughout the environment, getting the proper channel reuse, things of that nature, and not creating amongst yourself your own co-channel and adjacent channel interference. So let me bring up EcoHow. And this is a blank slate. What I'm going to be doing is layering on the different pieces as we talked about it. Obviously the first thing we did, we imported the scaled floor plan, which is what you see here. This is the scaled floor plan. The first thing we would do is scale that floor plan. So now I'm not going to go through, this is an EcoHow tutorial per se, but this guy here allows me to set scale to that facility there. So you can see the width of that church is almost 270 feet. So all of that was inputted based on the measurements I got from my site survey. So we import it, we scale it, and then if it was multiple floors, we're locking the floors. They've got the option to create anchor points, if you will, floor points between the floors, so you can lock those guys together so you can see signal bleeding and so forth there. In this case, I didn't have to do that. But drawing the walls, I had to draw the walls. So let me add that view to it so you can see the walls as it looks. So different draw walls, different center block, things of that nature, windows. This is a children's area here with nothing but windows. But with your wall measurements, this is where you can incorporate customization on the attenuation level of your walls or whatever materials. You simply, let me just show you real quick. Oops, sorry about that. So right here, drywall, if I wanted to modify that, I can just simply say, I measured this at 5 dB, and I can give it a different name as well. So you can, create the custom measurements and building material attenuation levels throughout that environment. And you start drawing the facility, right? You draw it throughout the facility. And the next thing I do is I'm placing my APs, but actually before I do that, let me show you the attenuation areas. Like the worship center here is going to be kind of a large attenuation area of humans as they get into the worship center. So let me show you that view. And I'll take off the label. But there I'm layering in the attenuation area so that the EcoHow predictive modeling, the propagation, is incorporating and adding that into its design. And then we're placing APs. So let me place APs and turn off names and antennas. But I'm placing APs. Now obviously there's a high concentration of APs in the worship center. This is to build up my capacity. These are directional T301Ns from Ruckus. Highly directional, 30-degree beam widths. So I'm tuning the power down way low. I'm making sure my channel plan is spot on. so that I can build up the capacity in this area. Everything else that you're seeing, these are R510s with a few exceptions. The rest of these are all R510 omnidirectional, strictly as a coverage play, nothing more. So if I turned on, let me just excuse me. There's the signal lap. Now, I mentioned earlier that I designed everything around 5 gigs and I sprinkle in 2.4. So right now this has got 2.4 and 5 turned on. However, if I flipped it over to just 2.4, you can see where there's gaps, and that's okay. That's intentional in this design. But with 5 gig, it's turned on. Obviously, there's some gray areas there where the signal's not quite where I want it to be, but these are to the customer areas of extreme importance. So now this wasn't a tutorial on Ekahau, but that's some of the layers I'm going into as I'm working with Ekahau based on the customer requirements, their pain points, the site survey. I'm layering all that information so I can come back to Ekahau and do my predictive modeling and such. So let's get back to our slide deck here. Deployment. So we've modeled actually, yeah, so we've modeled and such, but one thing I want to, before I talk about deployment, I want to talk about kind of a design presentation, if you will. I didn't include it in the slide deck here, but I like to then present to the customer. I show them what I went through to get up to the design that I'm presenting to them. I'm repeating the pains that I heard them say. I'm repeating all the requirements and expectations that they told me they wanted on the wireless network. And then I'm showing them my Ekahau design. I'm showing them how I came up with my capacity numbers with the Wi-Fi capacity plan. I'm showing them the different layers of Ekahau that I came to show them the resulting design. I'm showing them all that information. And I'm also at times educating them on just maybe fundamental concepts of wireless. I'm doing that to build trust and build confidence and credibility that what I did was not just some art project to create colors. It's a real design based on what they told me they wanted to have done. So that's an important element, and I thought I did a slide deck on that, but that's an important element that needs to be done. And of course, customer approves, we're deploying, right? So within, let me update my notes here. Within Ekahau, we've got the ability to do all kinds of reports. You can export images, things of that nature. So the reports can be kind of multifaceted, really. They can be reports for in-house within your own business. They can be reports that you can hand over to the installers so they know where to run cables, where to mount APs, all that good stuff. So we use that very liberally within Ekahau, so that as I'm handing off all of our designs to our cabling vendor who also mounts the APs for us, they know where they're going, all that good stuff. And also, I am provisioning APs in the office ahead of the installer. So I'm labeling, I'm provisioning based on the design, channel plans, power plans, VLAN assignments, rate limits if I'm doing that. I'm doing all that pre-provisioning ahead of time so that when I hand that off to the installer, I'm handing him a report that has something as simple as, let me show you this picture. The resolution isn't great, but he's able to know exactly where the APs are going. He's got pictures, he's got labels on Ekahau that match the labels that I've placed on the APs. So he's got all the information he needs to take my design and put it into a real world deployment. And then, once you've everything's been installed, you're going back on site and you're validating. And I'm talking about this part here is validating the physical work. We're not talking about validating Wi-Fi and such just yet, but I'm validating the physical work. I'm validating that you installed APs where I want them, the proper type of AP if there was multiple models, how you mounted it, did you articulate it correctly if it's a directional antenna, all that good stuff. Are the labels matching because every AP is provisioned for a specific area. So did you mount the right AP, all that good stuff. If they did cabling, did the cabling get verified? Is there a report that shows me every cable that was tested and what it was rated to, fiber test, all kinds of good stuff. I'm validating all the physical stuff because I'm not the guy physically doing it. I'm giving the design off for those guys to do that for me. So that's an important aspect of it. So, following deployment, you then got a post-deployment. Actually, my slides are a little out of whack. So, you got a post-deployment validation. Now, this, for like the church is when it's sitting empty, right? So I'm busting out the Ekahau and I'm doing a passive survey, and I'm also probably doing an active survey, testing throughput and things of that nature. So the passive survey getting me my signal propagation throughout the entire facility. Typically, I kind of combine passive and active at the same time, so I can do some throughput testing. Throughput testing, yeah, everybody's got their own way of doing it. One way that I've found that works well for me is I take my cell phone and I load up an iPerf application. I think it's called Magic iPerf. And of course, I pair that up with Ekahau, and I'm able to do a throughput test between my adapter on the laptop with the cell phone, so that as I'm doing a passive survey throughout the facility, I'm doing my throughput testing as well. You want to test roaming, things like, especially if you've got kind of latency sensitive, jitter sensitive applications, voice, what have you. You want to make sure that as you're roaming from AP to AP, that there's not enough to cause disruptions in that service. In the church's case, it was simple. I mean, for the most part, it was applications that were not latency sensitive, not jitter sensitive, things of that nature. I also like to test IP addressing and segmentation. So I like to hop from one SSID to another to make sure that I'm getting into the right VLAN with the right IP assignments, things like, as well as if I've enabled client isolation, I want to test that to make sure I truly can't communicate with another device while I'm on the public SSID, for example. And of course, applications, testing all the applications that were given to us and the requirements. Now, right now, this is an empty church right now in this case. I do a kind of a go live visit, if you will, to where I'm testing all these same kind of check marks in kind of a go live situation. Let me show you a quick site survey I did with one of the church's surveys, so you can kind of get some eyes on that. Just kind of see what I'm talking about as far as doing passive, active surveying, throughput testing, things of that nature. So this is one of the surveys I did at the church. You can see the paths that I walk throughout the facility, gathering information passively and actively through a throughput test. So I can, once again, kind of layer on some things so you can visualize what the results were. So quickly, just kind of showing you just signal strength overlay, kind of the passive side of that survey, so that I can see that what I predictively designed was matching up with real life. So that's an important element there. And once again, this is not a tutorial in Ekahau. I'm not going to go through all the ins and outs of how to do the survey, but nonetheless, the element of surveys is an important part of your post-deployment validation. Also, just so you can see it, let me throw on the throughput. I was doing an active throughput as well as I was walking the facility. Now, this obviously looks like it's gapped, like there's issues. What you're seeing here in these gaps, where there's no representation of throughput, once again, I was doing it with my cell phone, if you recall, with that Magic iPerf app. And so at times, if you're not watching it, the phone can essentially go to sleep, at which case my active throughput stops. And that's what you're seeing here in these gaps, is when my cell phone decided to quit on me. Excuse me. But also you can see some concepts of typically what's kind of thrown out there as a sticky client. You can kind of see where, as I was walking, getting further and further to the side, my cell phone was continuing to maybe stay associated with a guy here as I came further and further into the corner. So my throughput levels were getting less and less as my SNR got worse, all that good stuff. It was downshifting as I was getting further and further away from the AP. So once again, you can't control that. We can do our best to try and encourage the clients to connect to the best AP, but in some cases you can't control what that driver's going to do. So it's a good representation of that. But basically I can kind of put my mouse over a certain area, and it's going to, if I sit still for a second, it's going to tell me in that particular spot what my throughput was that I was getting from my test. You can see what the adapter was, my Dell Wireless, my internal adapter, as well as the host, which in this case was my cell phone. So anyhow, so you can just kind of go throughout the facility doing throughput testing, so you can make sure that based on requirements, you've hit those requirements. So back to our slide deck. The last thing basically is, like I mentioned earlier, go live. I don't want to do just a post-deployment validation when the church is empty or when the customer's facility is empty. I want to do kind of the same stuff, but when it's being used. So in the church's case, I actually went to one of their Sunday services and kind of went through all those processes that we just went through from the post-validation side. So I was checking all the different areas. For example, their check-in processes for their kids. Was their POS functioning with people in the concourse area? Was it locking up, or was it being smooth and performing like we expected it to be? Their volunteer check-in, they got volunteers that volunteered all kinds of different areas of the church. Was that check-in properly negotiating and printing out labels for the folks at the church? They have kiosks for tithing. Was that guy properly connecting to the network and doing what he needed to do to receive the tithes that the different folks may be giving? And like I mentioned earlier, they've got a church app. So I got to make sure that app is working during the church service, not just when the church is empty. That's kind of easy, right? I got to make sure that things are performing while the church is being used, while your customer's environment is being used. Also, I like to kind of see what my spectrum looks like as well. You got in your head, you got your predictive model, but the live environment, the real life scenario is important. So I'll bust out the spectrum analysis as well. And I'm looking at 2, 4, 5 gig, whichever bands that were a part of my design. I'm looking at utilization. Am I seeing anything in the spectrum that's different from what I saw when I was doing all of my designing and things of that nature? Is there an RF energy that I didn't know was there, like at the church? Was there a new RF when they fired up all their microphones and different audio-visual gear? Things like I've got to watch all those things that you wouldn't see when the church is empty. So that's important. And of course, I'm watching client counts too with the Ruckus controller on the Smart Cell inside. I was trying to look at my reports and making sure client distribution was proper and spread out. There wasn't an AP associating a ton of clients when it shouldn't be, those kind of things. I was watching all that stuff. And then of course, customer experience is king. No matter what, your metrics, your reports, your all of your modeling, all your tools, no matter what it's saying, it's rubbish compared to the customer's experience and what they are saying they are experiencing. So I was talking to people. I was talking to church staff. I was talking to people in the members of the church, things like that, getting feedback of, was this working? Was this working? Were you happy with that? All those things are important to kind of wrap up that whole project. So like I said, guys, this is not exhaustive. This is kind of hitting some of the high core fundamentals that I go through as I hit different designs, specifically kind of medium high density. So guys, I hope that you enjoyed today's video. I trust that it was informative, and thank you for watching.